Okay. So they are saying like complete the table to show some properties of quadrilaterals. So you are aware about like how many different kind of quadrilaterals we have? Like how we divide quadrilaterals in categories? Yes or no?
No.
No? Okay, so
No.
before doing this question, we need to have a knowledge on that, okay? So let's start with that. So if I tell you like about quadrilaterals, so first of all, just tell me like what do we mean by a quadrilateral? What does the what's the meaning of this word that we are like writing?
A shape with four sides.
Perfect. A shape made up of four sides. Or you can also call it a polygon. A polygon with four sides? Yes or no?
Yeah.
Okay. What do we mean by a polygon? Which shape is known as a polygon?
Square.
Yeah.
Rectangle.
What it is? What's a
Triangle.
polygon?
A regular shape.
A regular shape. Regular is a different word. We will use regular separately. Regular, irregular are different things. But what is a polygon first of all? You just have to say if someone asks you a polygon, then you just have to say a closed shape, okay? A closed shape made up of what? Made up of straight lines, okay? Okay, then next question can be how many lines are needed to make a closed shape? At least like minimum number of lines that you require to make a closed shape. How many line segments are required? Let's say I'm using just a one. Is it making any shape? No. Yes or no?
No.
Then let's say I use two. Is it making any closed shape?
No.
No. So minimum number of line segments that you require to make a closed shape, which is made up of straight line, is a what? What kind of a shape it is?
Triangle.
Triangle. So how many minimum number of sides are required to create a polygon? So to
Three.
create a polygon, we require three sides, okay? So the three-sided shape is known as a triangle, and the four-sided shape is known as a what? A
What?
quadrilateral, okay? And this way, like the we will move ahead. You can say 5-1 is known as a pentagon, 6-1 is known as a like hexagon. Yes or no? This way it will continue. Get it?
Yeah.
Okay, no
Yeah.
confusion in that. Okay, so for right now, we need to specifically read about or discuss about what? We need to specifically discuss about quadrilaterals. So what are quadrilaterals? So a closed shape made up of four sides, we can say. Now, if you divide the quadrilaterals into subcategories, so what are the three different? There are like just three different categories that you will have. So few shapes are trapeziums. A few quadrilaterals are trapeziums. So what are these names came from? Just based on the arrangement of the sides that we are doing, okay? You have four sides. So how you are differently arranging these four sides will give you a new shape, okay? So the first shape, a first special type of quadrilateral is a trapezium. Second one are the parallelograms, okay? And the third one is a kite, okay? So do you know like what are the special properties they have? What's special about a trapezium? What's special about a parallelogram? And what's special about a kite?
Yeah.
What you will say?
Yes.
So what is special? Like I'm asking.
Like parallel line.
Okay, for a trapezium, what we have?
Parallel line.
All the lines are parallel.
Two lines.
To which two? Like you have to specify.
Top and bottom.
Sorry,
Top and bottom.
the opposite pair. Okay, you have to say one pair of opposite side is parallel. Like if I make a trapezium for you, so this one is a trapezium for us, yes or no? Because these
Yeah.
pairs of sides are looking parallel. So one pair of side is parallel and one pair of side is non-parallel. Get it? This can
Yeah.
look like, you can say this way as well. Is it still a trapezium? So you will say yes, because you have again the one pair of side as the parallel. Yes or no?
Yeah.
Good. So if one pair of side is opposite pair of side is parallel, then you're going to call it as a trapezium. Okay. Anything special about it? Is there any other property that you need to know? Yes, or you remember? What you will say? Yes, you're like know about it or not?
No.
No? Okay. So these two lines are parallel, like the two black lines are parallel. So what's the relation between these two angles? Is there any relation?
They're equal.
Are they
They add up
equal?
to they add up to 100.
Yeah, they add
Yeah.
up to 180. And the reason why?
Uh,
Do you know the reason? Because in case of a pair of parallel lines, if you draw a transversal, these two angles are known as what? Co-interior angles. Yes or no?
yes.
Yeah. So the sum of co-interior angles, or you can say the co-interior angles are supplementary. Okay. So we can say like if this one is A, this is B, this is C, this is D. So A plus D will give you 180 and C plus B will also give you 180. This is one of the property that we have for a trapezium. Then comes like there is one more special type of trapezium. We call it as a isosceles trapezium. Isosceles, like what it is, if you are aware about it. How you can make a trapezium as a isosceles? Are you aware
Uh,
about it?
no.
No?
Uh,
Okay. So look at there, like if you have just a trapezium, normal trapezium I will make first. So if you look at this trapezium, so just one pair of opposite side is parallel, yes or no?
yeah.
So how we can make it an isosceles trapezium? So you have to say if this pair of non-parallel sides, this is a pair of what? A non-parallel side, yes or no? So if they will become equal to each other, then you will get a isosceles trapezium. Okay. So what's the property? Like if the non-parallel pair of side becomes equal, then we name it as what? We name it as a isosceles trapezium. It still have the pair of parallel side, but the non-parallel sides are equal now. Get it? Any
Yeah.
confusion?
No.
No. Now they have some special property. So what's that special property? So you can say like the point or the vertices where these non-parallel sides are meeting with the parallel sides, those angles are equal to each other. So we can say angle D is equals to angle C, okay, and angle A is equals to angle B. This is a property they have. Get it?
Yeah.
So adjacent angles on what? Adjacent angles on the parallel sides are equal. Got it?
Yeah.
Okay, good. And there is a one more property on the basis of diagonal. So the property on the diagonal is what? The diagonals are equal in this isosceles trapezium. Okay?
Yeah.
Any confusion out there?
No.
No. So how many properties we got? One pair of opposite sides are parallel. Then the angle between the adjacent angles between those parallel sides are what? They are adding up to 180. And then the vertices where the non-parallel sides are cutting the parallel sides, the angles that they are framing, they are equal to each other. Get it? So the
Yeah.
angles that are at bottom, A and B, they are equal, and angle D and C are also equal. Get it?
Yes.
Okay, good. So I hope like the trapezium is clear to us. We can move ahead.
Yeah.
Okay, good. Now the next thing we will move towards the parallelograms. So what are parallelograms? What you will say?
Um, it has two, two pairs of parallel lines.
The opposite pair of parallel sides. Okay, the opposite pair of sides are parallel and equal as well. So if I draw a diagram for you, first of all, like it look like a rectangle, you can say. Okay, just the corner angles are not 90, you can say. Get it?
Yeah.
Okay, so look at there, this shape that I made right now, A, B, C, D. So what I can say about it, this AB is parallel to CD and this CB is parallel to AD, and then this one is equal to this one and this one is equals to this one as well. So what point we can mention? We can mention opposite pair of sides are equal and parallel. Okay. Point number two. This point is clear now. Like if this side is 5 centimeters, so this will come out to be 5 as well. If this is 2 centimeter, it will come out to be 2 as well. That's the meaning of this point. Got it?
Yeah.
Okay. Then if I talk about pair of adjacent angles, what you will say about it?
They're equal.
They are equal. Are you sure? This adjacent means the neighbor angles. So which angle is neighbor to the D angle? The C. The C angle is neighbor to D, and A angle is also a neighbor to D. So what's the relation they have for the adjacent angles?
Add up, add up to
Add up to
180.
180. Okay. So pair of adjacent angles add up to 180, or you can say they are supplementary. Perfect. We can move next.
Yeah.
Okay, good. Then the next thing that we will discuss about this parallelogram, or the next property about is opposite angles. Okay. So what the relation they have for opposite pair of angles? So you're gonna say the opposite pair of angles are equal. Okay.
Yeah.
So what's the relation? Which
They're
angles are
equal.
opposite? Just name them till the time I'm
A,
writing.
A and C.
A and C, and one more pair is there.
C and D.
Yeah, B and D. Opposite pair of angle are equal. So what are opposite pair? Angle A is equals to angle C, you can say, and angle B is equals to angle D, we can say. So these are the opposite pairs we got. Okay, is there any other property? No?
No,
What about diagonals? We forgot about diagonal. We haven't discussed any property on diagonal for it.
they're equal.
Yeah, they are equal. Are you sure? They are not
Parallel.
equal. They bisect each other, okay? Diagonals bisect each other in a parallelogram. They are not equal. Get it?
Yes.
So one diagonal can be of 6 centimeter, one diagonal can be of 5 centimeter. Okay, it is possible. But the 6 centimeter will be divided into 3 and 3 centimeter, and the 5 one is divided by the another one into 2.5 and 2.5. Got it? So we can mention the diagonals bisect each other. Got it or not? So these are the 4 points that you need to remember as a property for a parallelogram. Okay.
Yes.
Any confusion?
No.
No. Okay, let me make a line on this side as well. Now if we move down a bit, so these parallelogram, like this parallelogram family that we just discussed, is like expanded later on. So how we expand it? So you can say the parallelograms. Let me write it. if you add up few properties in the property of parallelogram, what are the four properties? Let's recall it again. Opposite pair of sides are equal and parallel. Adjacent angles are adding up to 180. Opposite angles are equal and diagonals are bisecting each other. Get it?
Yes.
Okay, good. Now if we add a few more properties in the properties of parallelogram, then you will get the three different shapes. So what are the names of three different shapes? Yeah, do you like you're aware about them?
Rhombi.
Rectangle,
What?
rhombus, and then in the middle you can say a square. Get it?
Yes.
Okay, what's the rectangle property we have? So these four properties are still there, okay? The properties that we discussed, they are still there. Now we will be adding two and two more properties. So what are those two properties you get? So you can say in rectangle, each angle is 90, okay?
Yes.
The corner angles are 90-degree, and then the diagonals are also equal. Got it? Yes or no? Means
Yes.
if you make a rectangle out there, then both the diagonals will come out to be same. Let's say if one of diagonal is given to you as 5, other diagonal will also be 5. And if someone asks you, will they bisect each other as well? So what you will say?
Yes.
Yes, 2.5 and 2.5 will be the part that you will divide them, okay? Get it?
Yes.
Okay, then comes what? Then we will discuss about rhombus. The second one is a rhombus that we need to discuss. So what are the properties that a rhombus have? Two more properties. Like all the property of parallelogram plus two more extra properties we will have. Not the rectangle ones, okay? Rectangle ones are different. So what is a rhombus? So you can say all the sides are equal. All sides are equal to each other. Get it? And
Yes.
then the next property that we will add on is about, you can say, the diagonals. So diagonals are crossing each other or bisecting each other at 90-degree. They were bisecting previously as well in a parallelogram, but over here what is happening? Bisecting each other at 90. So means when the diagonals will cross each other, they will make a 90-degree angle. Get it?
Yes.
Okay. So diagonals bisect at 90-degree. So these are the two properties that we add on in the rhombus. So what about a square now? What you will say?
Uh,
Yeah.
each angle is equal.
Each
90
angle is
degrees.
equal, diagonals are equal, diagonals bisect each other at 90, and all sides are equal. Get it? So
Yes.
means I can say if I mix up the properties of what? If I add up the properties of rectangle and rhombus and the parallelogram, then I will get a new shape named as a square for me. Yes or no?
Yes.
So these 4 points that I mentioned for rectangle and rhombus, they need to be included to make a square. Got it?
Yes.
Any confusion?
No.
No. So we are done with the parallelograms as well. Okay?
Okay.
Any confusion?
No.
No. Okay. So we are just left with one more shape, and that is what? That is a kite. So let's have a discussion on kite as well. So what's a kite? You can say the kite look like this. Okay, just 1 second. So the adjacent pair of sides are equal. Okay, in a kite. Like in none of them, we haven't got the adjacent pair of sides equal. Do we get any pair? So you will say no. But in this one, what they have arranged, so they have made like this. These two pair of sides are equal, and these two pair of sides are also equal. Okay, get it? Okay. So what we can mention? What we can mention for it? So you can mention that the adjacent pair of sides are equal. That's the first property we got. So adjacent pair of sides are equal. Is there any pair of side parallel? So you will say no. There is no pair of side parallel to each other. Get it? Okay. Then comes the second property. So for the second property, the rule is what? The rule is just saying the point where these non-equal sides are meeting. Okay. These angles are equal. So you can say angle D is equals to angle B. And how you can write it? So you can say the vertex angle where the non-equal sides meet are equal. Get it? Okay. Any confusion?
Yes.
Okay. Then comes the diagonal point. So what about diagonal? So if I make a diagonal over there in the diagram, so you can say there are two diagonals. One is a longer diagonal and one is a shorter diagonal. Yes or no?
Yes.
And these diagonals are also crossing each other at what? 90
No.
degree. Okay. So we can mention it as a point that, okay, one more thing. The bigger diagonal bisect the shorter diagonal. Okay. So we can mention the bigger diagonal bisect the shorter diagonal. Do you know the meaning of this word bisect?
Yes.
What's the meaning?
Cross.
Cross. Just a cross.
Uh,
The meaning is, the real meaning is like, let's say this line is 4. Okay. And if this is bisected by this line, so what I can say? I can say this part is 2 and this part is 2. That's the meaning of bisect. Get it? So bisect means dividing equally. Okay.
yes.
Is it clear?
Yes.
So whenever you get a word bisect means dividing equally in two parts. The bi word bi means dividing in two parts. Okay. And both the parts will be equal. So the bigger diagonal bisect the shorter diagonal and they cross each other. They make 90-degree angle when they cross each other. Okay. Each other by making a 90-degree angle. Any confusion?
No.
No? So if we just recall like whatever we have discussed in this, so this is the whole thing we can say. The quadrilaterals, you can say a shape with four sides. Then you can say trapezium, parallelograms, and kite are the three categories in which we divided our quadrilaterals. Yes or no? Yeah. And then later on, you can say like the trapeziums are one pair of opposite side is parallel. If you want to say isosceles trapezium, so the non-parallel sides are also equal, then you can call it isosceles. After that, we discuss about parallelogram. So we have four properties for it. Opposite pair of sides are parallel and equal. Diagonals bisect each other. Adjacent angles add up to 180 and opposite angles are equal. Get it? Now, if you
Yes.
divide the parallelogram family, then you have rectangle, square, and rhombus. So, rectangle have two more additional properties from parallelogram, and rhombus also have two additional properties as compared to parallelogram. And then, if you mix up those two and two properties of rectangle and a rhombus, you will get a square. Is it clear?
Yes.
So now we can do that question like in which you are having a doubt. So let's see that. So what they are saying, like let's read out the property. For parallelogram, they said both pair of opposite angles are equal. Yes, opposite angles are equal. Yes or no? Diagonals are
Yes.
equal in length? No, diagonals are not equal. They just bisect each other. Yes or no?
Yes.
Good. Then about a rotational symmetry means if you rotate it, how many number of rotations you have to do so that it will become same. So how many rotations? Just after two rotations. Okay, get it?
Yes.
Okay, good. Then comes the rhombus. So if we discuss rhombus, so both pair of opposite angles are equal. Yes, because it is a property of parallelogram. So it will be yes everywhere. Okay, get it? Only for a kite it will be a no because kite is not a parallelogram. Okay,
Yes.
so you need to put a cross on this one. Get it? Now if we
Yes.
discuss the next property, diagonals are equal in length for a rhombus. No, they are not equal. Because in parallelogram they are not equal, so in rhombus also they are not equal. Only in a rectangle or a square they are equal. Yes or no?
Yeah.
So that's why it is also a no. Rotational symmetry of order 2. So yes, it have a rotational symmetry of order 2, you can say. Okay? Because
Okay.
parallelogram have it, so it will also have it. Okay? Then comes the kite. So kite, like we just discussed, right, on this side. Both pair of opposite angles are equal? No, only one pair of opposite angle is equal. D and B are only equal. A and C are not equal. Okay? So that's why it is a no. Get it?
Yeah.
What about diagonals equal in length? What you will say? Yes or no?
Yeah.
They are equal for a kite?
Oh no.
No, they are not equal. Okay? Then rotational symmetry of order 2? No. Okay? It will not have it. It's like if you rotate it completely, then only like it will look similar to it. There is no rotational symmetry, you can say. Okay? Of order 4 it have, you can say. The 4 rotations we need to make, then like it will look like same. Then what about rectangle? Just tell me each property. Look at there and read it. In rectangle, both pair of opposite angles are equal. What you will say?
Yes.
The reason?
Um, each angle is 90 degrees.
Perfect. Second, diagonals are equal in length.
Yes.
Yes. Okay. And in how many shapes the diagonals are equal?
Two.
Which two?
Square and rectangle.
That's it. Means you got it. Okay. Then rotational symmetry. So you will say a yes. Okay.
Yeah.
So any confusion out there?
No.
No. Good. So this type of question like can confuse you if you don't remember the properties. Okay. So just remember them